So today we're going to do some more work with proving that triangles are similar and finding some missing dimensions. So in this diagram below, CB is parallel to DE, and that's important to know because it helps us find some angle measures. So if we have this line here parallel to this one, that means that they're hitting this line at the same angle measure, which is going to help us prove some angles being congruent because it's kind of like having parallel lines cut by a transversal. So first thing we want to do is think about some of the angle measures. Well, if this one is 20 here, this one also has to be 20 because those are vertical angles. Then we can go into finding the third angle in each of the triangles to prove that they are all congruent and therefore the triangles are similar. So we have 84 and 20 makes 104. And then 180 minus 104 is 76 degrees. And then in the second one, we have 76 and 20 makes 96. And 180 minus 96 is 84. So now we've proven that our triangles are similar because, once again, remember that phrase from yesterday, all of the corresponding angles are congruent. So yes, the triangles are similar. Because all of the corresponding angles are congruent. Now, part B says, write and solve an equation to determine the lengths of the sides given as algebraic expressions. Well, there's only one side given as an algebraic expression, and that's this x here. The tricky part with doing this is, first of all, knowing that an equation can be a proportion. A proportion can be an equation because it has an x value in it that needs to be solved. So in this case, we have corresponding sides, just like we saw yesterday, and we need to set it up as a proportion to solve for x. The tricky part is making sure that we set up the equation correctly with the correct corresponding sides. So if we take a look at this diagram, if we were to rotate the larger triangle 180 degrees around the vertex, it would match up perfectly with the smaller triangle. And that would help us think about what sides are corresponding. So if we were to do that, the 9 would rotate on top of the x. So that means those two sides are corresponding. So if I'm setting up my proportion and I want to do the smaller triangle over the larger triangle, I would have x over 9 equals, and thinking about that triangle being rotated again, the 8 would be with the 12, so 8 over 12. Cross multiply, x times 12 is 12x, and 9 times 8 is 72. Divide by 12, and x equals 6. So we've found our missing side. Okay, so number 2 is going to be similar to that. Let's go through and see what we can do with that one. So again, in this case, we have two triangles that we have to prove are similar before we can go ahead and find the missing values. So in this case, we have 90 and 90, then 34 and 56. So we want to prove that the third angle in each of these cases would make these two similar. So we have 90 plus 34 is 124, and 180 minus 124 is 56 degrees. Since this one is 56, it corresponds with the top one in the other triangle, so we have enough information to know that this one is also going to be 34 degrees, and that, once again, the triangles are similar because the corresponding angles are congruent. So now we're going to go through and write an equation to solve for those missing sides. So we have 15 is going to be similar to the 16, and 4x minus 2 is going to be similar to the 4x. So we could write our equation. I'm going to do this over here, even though you want to write it on the bottom. We have 15 is similar to 16 as 4x minus 2 is similar to 4x. So just like we did with other proportions, we're going to cross multiply first. So we have 15 times 4x. 15 times 4 is 60, so we have 60x equals 16 times 4x minus 2. So I'm going to write that this way so you see it, because that means I'm going to have to distribute. So we have 60x equals 16 times 4x is 64x. 16 times negative 2 is negative 32. Now I can solve for x, so minus 64x. And I get negative 4x equals negative 32. Divide by negative 4. And x equals positive 8. So that hasn't given me the sides, it's only given me x, so now I got to plug that back in. So 4 times 8 here means that this side is going to be 32 centimeters. 4 times 8 here minus 2 means that that side is going to be 32 minus 2, or 30 centimeters. All right, I'm going to do one more example with you before you're on your own. So turn to the next side. And here we have some overlapping triangles, and again, some parallel and perpendicular sides. So BE is parallel to CD, these two here. And CD is perpendicular to AD, I think it should have said. I don't know why it's just saying D there. So perpendicular means that they have 90-degree angles. So in both cases, these are perpendicular. All right, so they share this angle A as 28 degrees, and they both have 90-degree angles. So that's going to prove that they are similar right there, because they have two similar angles. But we can find the third angle by doing 90 minus 28, or 90 plus 28 rather, is 118, and 180 minus 118 is 62. So this is going to be 62, and this is going to be 62. So once again, the triangles are similar. Because the corresponding angles are congruent. Okay, so now we have to set up our proportion. And in this case, it gets a little bit tricky. So write and solve an equation to determine the lengths of the sides given as algebraic expressions. So in this case, the 5 is similar to the 10, going smaller to bigger. Then smaller to bigger again, AE is just 3x, but A all the way over to D is the 3x and the 12, so 3x plus 12. Cross multiply. 10 times 3x plus 12, or no, sorry, 5 times 3x plus 12, and 10 times 3x. 10 times 3x is obviously 30x. And then 5 times 3x plus 12, I'm going to have to distribute. So we get 30x equals 15x plus 60. Subtract the 15x. And 15x equals 60. Divide by 15. And x equals 4. So now I know that AE, the 3 times x, is going to be 3 times 4, or 12. And then A all the way to D is going to be 3 times 4, which is 12, plus another 12, or 24 inches. So the next one is similar to that. You're going to try it on your own and answer the questions and go formative, and I'll be around to help you out.